This tiny plastic boat is floating upside down in a layer of levitating liquid. It looks like a gravity-defying magic trick, but in this case the magic is in the science and the mathematics behind this counterintuitive new phenomenon. To start with, we need to explain how a layer of dense liquid can be suspended on a layer of less dense air. The answer is vigorous vertical shaking. This part isn't a newly discovered phenomenon, though it can be tricky to demonstrate. Take this dense blue liquid in a glass container. When you flip it upside down, it starts to fall due to gravity. It doesn't just move down all in one mass, though. Like paint falling down a wall, it starts to drip. The bottom surface bulges into droplets, which fall, displacing the air underneath, until it ends up all in a layer at the bottom, as you'd expect. But if you place the container on a shaker set to a suitable frequency, something unusual happens. Once the blue liquid is fully upside down, it stops dripping. The vibrations prevent the droplets from forming and keep the whole bottom layer of the liquid nearly flat. And if the droplets can't form, the liquid can't fall. It's floating on a trapped cushion of air and contained by the glass on either side. It's compressing the air below it, but it can't displace it, so it hovers in place. While this was already known, researchers in France have been exploring another, even more counterintuitive effect of the shaking. When they place a boat or a light plastic ball at the bottom surface of the liquid, it floats in place, just like it would at the top surface. This is partly because the air pressure underneath the ball is quite high, since the air is being compressed by the weight of the liquid pressing down on it. But as you go up the liquid layer, the pressure decreases, as there's less water above it pushing down. This results in the ball or boat being pushed up by the pressure underneath. That is, until it reaches an equilibrium point, where that upwards force is balanced out by the downwards force of gravity, and it floats. This balance of forces is what causes buoyancy, and that's exactly what's happening here too, albeit upside down. But the most puzzling thing about this upside-down floating effect is that it's stable. If you gently push or pull the boat, it'll bob back to its equilibrium position, just like its right-side-up counterpart does on the surface. The researchers mathematically modelled the forces involved, and sure enough, the figures predict this bizarre, stable reversed buoyancy. It may seem contradictory to all common sense, but the maths checks out. The effect does depend on the system being shaken hard enough though, and at the right frequency. If the vibrations get too small and gentle, the ball and the liquid will eventually fall. But get the shaking right, and that is how science can lead to a boat floating upside down on a levitating layer of liquid. Not with magic, but with maths.